Hello friends, my name is Akshay Elwame. I welcome all of you to my YouTube channel Mass State Board Education. So in today's video we are going to learn the determinants. Okay, so let's see guys what is the determinants. Okay, so if we write the terms in the form of A, B, C, D. Okay, so if we write the term in the form of these, we can call this as a determinant. Okay, so determinant, there are in this determinant there are two rows. Okay, two rows, the horizontal two rows. This is first row and this is second row. Okay, and 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 this determinant also has two columns. This is column number 1 and this is column number 2. Okay, so this determinant is the order of 2 by 2. Okay, so this determinant is of the order of 2 by 2. That means 2 rows and 2 columns. Okay, so look, let's see the row values. So row values include a comma b. Okay, so we call a comma b as a row value. Okay, in that is the first row value, and second row value is c comma d, and first column value are a comma c and second column value are b comma d. That is the two element in the each row or two elements in the each columns. That is our determinant is of the order of 2 by 2. Okay, so this is about how to identify the order of determinant. So how we can solve this determinant. So to solve this determinant, we have to just do the cross multiplication of these terms. Okay, cross multiplication of these terms and take difference of these two terms. So let's see, if we solve these determinants, we will get a into d. Okay, cross multiplication minus c into b. Okay, so this is solution for the determinants. Okay, so let's see some example how to solve the determinants. So we have taken the cross multiplication like this. Okay, or this, like this. Okay, and then we took the difference between these multiplication values, and if we solve this value, we get the final value for our determinant. So let's see the examples. Okay, so let's see the example from the practice set 1.3. Okay, so let's see example from the practice set 1.3. Okay, so first fill in the blanks with the correct number. Okay, so here determinant is, what is determinant? 3 2 row values 3 2 and 3 2 and 4 5. Okay, so if we want to solve this determinant, we have to just take the cross multiplication of these terms. Okay, cross multiplication of these terms. So to calculate the determinant value of these, let's see, is equal to 3 into 5. Okay, 3 into 5 minus 2 into 4 or 4 into 2. Okay, so is equal to 15 minus 8. So we get the determinant value is equal to 15 minus 8, that is 7. So value of this determinant is 7. Okay, so you can write here, you can fill this blank as a 3 into 5 minus 4 into 2 or 2 into 4. Okay, so is equal to 15 minus 8, so is equal to 7. So let's see another example. Find the value of following determinants. Okay, following determinants. So let's see the first determinant, minus 4 7 2 4. Okay, so first determinant is what is it, minus 1 7 2 4, minus 1 7 2 4 2 4. Okay, so to solve this determinant we have to just cross multiply these terms and take a difference. Okay, so minus 1 into 4 into in bracket minus second multiplication 2 into what, 7. Okay, so 2 into 7, so we get the value minus 1 into 4 minus 4 minus 2 into 7 14. Okay, so we have to add this minus 4 minus 14, so is equal to minus 18. So value of this determinant is minus 18. Okay, so look this solution again. So we have taken the cross multiplication like this, minus 1 into 4 minus 2 into 7, so we get minus 4 minus 14, then we get final value is equal to minus 18. So let's see the what is the Cramer's method to solve this simultaneous linear equation. Okay, so let's see the Cramer's method to solve the simultaneous linear equation. Suppose we have two simultaneous linear equations, okay, such as a1x plus b1y is equal to c1, okay, and a2x plus b2y is equal to c2. Here a1 b1 are the coefficient of the x and y variable, and a2 b2 are the coefficient of x and y variable for the second equation, and a1 b1 are for the first equation, and c1 c2 are the constant. So if we want to solve this simultaneous linear equation by Cramer's method, we have to find out the three determinant values. Okay, so three determinant values are delta x and delta y. So how to find out this value of determinants, let's see. So if we want to find out the value of delta, okay, so value of delta, to find out the value of delta we will take the determinant. Okay, we will take the determinant by just omitting the constant term. Okay, so to find out the value of delta we are going to eliminate these. Okay, we are going to eliminate these. Okay, so we are going to eliminate these. Okay, so if we have to find the delta value. Okay, so let's see how to find the delta value. So delta value is equal to a1 b1, okay, a1 b1 and a2 b2. Okay, so now we can easily solve this determinant to find out the value of delta, as we have learned to solve the determinant. Okay, so in next step we have to find out the delta x value. Okay, so delta x value, so how we can find the delta x value? To find out the delta x value, okay, to find out the delta x value, what we have to do? So you write here, so delta x value, delta x is the at the bottom of the delta, not to multiply. Okay, so at the so let's see delta x. So if we have to find the delta x value, we have to just replace the coefficient of a1 a2 by the constant term c1 c2. That means we get the delta x as a c1 b1, okay, c1 b1, and here is c2 b2. So you can easily find out this delta x value by just solving this determinant. So in the next step we have to find out the delta y value. Okay, so delta y value, so to find out delta y value, okay, delta y is equal to, we have to replace the coefficient of y variable by the constant c1 c2. So we get the a1 c1, okay, a1 c1 and a2 c2. Okay, so you can find the delta y value. So by finding out these three determinants, now the next step is to find out the value of x and value of y, that is solution for the given simultaneous equations. To find out the value of x, we have to just take the division of, so that is x variable is equal to delta x by delta. Okay, so this is the solution for the x variable. Okay, and to find out the y variable, we have to take the y is equal to delta y by delta. Okay, so in this way we have learned the how to find out the solution for simultaneous linear equation by the Cramer's method. So let's see the example. Remember one thing, this delta x means the x is at the subscript of the delta, not to multiply to delta. Okay, so remember this. Let's see the example from the question set. So let's see the example number 1, that is 3x minus 4y is equal to 10 and 4x plus 3y is equal to 5. Okay, so let's write down 3x minus 4y is equal to 10. 3x minus 4y is equal to 10. Okay, so this is equation number 1, and second is 4x plus 3y is equal to 5. 4x plus 3y is equal to 5. Okay, is equal to 5. This is second equation. So by solving this method, by solving this equation with the Cramer's method, we have to calculate the delta determinant, then delta x determinant, then delta y determinant, and we have to just take the division of delta x by delta, so we get the x variable, and then we have to just take the division of delta y by delta to get the y variable. So let's see. First we calculate the delta determinant. Okay, so to write the delta determinant, we have to just take the determinant of the coefficient of variable x and y from the both the equation by eliminating or by omitting the constant term. So we get here delta is equal to 3 4, okay, and minus 4 3, okay. So by solving this determinant, we will get the value of delta. So to solve this determinant, take the cross multiplication as we have discussed, or as we have learnt. 3 into 3, okay, 3 into 3 minus, okay, into in bracket 4 into minus 4, okay. So 3 into 3 9 minus into in bracket 4 into minus 4 minus 16, okay, minus 16. So we get the value of delta is equal to 9 minus plus 16. So we get the delta is equal to 25. Okay, so delta is equal to 25. Now we have to find out the delta x. Okay, to find out the delta x, we will take the determinant by eliminating the or by replacing the coefficient of x from the given equation by the constant term. Okay, by the constant. So here delta x is equal to 10 5 minus 4 3 minus 4 3. Okay, so we will get the delta x value by solving this determinant. Okay, so delta x is equal to 10 into 3 minus into in bracket 5 into minus 4. Okay, 5 into minus 4. So 10 into 3 is 30 minus into in bracket 5 into minus 4 minus 20. Okay, so we get is equal to 30 minus 20 means plus 20. Okay, plus 20, that is we get delta x is equal to 50. Okay, delta x is equal to 50. Now we have to calculate the delta y value. Okay, delta y value. So to write the determinant for delta y value, we have to replace the y variable by the constant. Okay, by the constant. So we will get 3 4 determinant as a 3 4 and the constant term 10 5. Okay, so we will get the delta y value by solving this determinant. So let's solve this determinant. So is equal to 3 into 5 minus 4 into 10. Okay, 4 into 10. So 3 into 5 15 minus 4 into 10 40. Okay, 4 into 10 40. So delta y is equal to minus 25. Okay, minus 25. So to calculate the x value of x variable, okay, to calculate the value of x variable, we have to x is equal to delta x divided by delta. So we have both the value of delta x and the delta. So delta x is 50 and delta is 25. So 50 divided by 25, we will get x as a 2. So x is equal to 2. Okay, x is equal to 2. Or to calculate the y variable, okay, so y is equal to delta y divided by delta. So we have the value of delta y as a minus 25 and delta is 25. So we get the y variable as a minus 1. So this is our final solution. So we can write our final solution as x comma y is equal to 2 comma minus 1. So this is the final solution, okay, for the given simultaneous linear equation by the Cramer's method. Okay, so let's see guys what we have do to solve the simultaneous linear equation by the Cramer's method. First we have calculated the delta determinants. To calculate the delta determinant, we have just omitted the constant term and we took the determinant of the coefficient of the both the variables from the both the equations. So we get the delta as a 3 4 minus 4 3. Okay, so we have solved this determinant to calculate the value of delta. Then we have calculated the value of delta x by just replacing the value of coefficient of variable x from the both the equation by the constant term. So we get the determinant 10 pi minus 4 3. We have solved this determinant to get the delta x value. So we get delta x is equal to 50. So in next step we have calculated the delta y by just taking the determinant by replacing the coefficient of y variable from the both the equation by constant terms. So we get the determinant as a 3 4 10 5. So we have solved this determinant to find out the delta y value. We get the value of delta y as a minus 25. So to calculate the value of x variable, we have take the division of delta x by delta. Then we get the x as x is equal to 2. And to calculate the value of y variable, we have taken the division of delta y by delta. So we get the y is equal to minus 1. So our final solution is x comma y is equal to 2 comma minus 1. So thank you guys for watching this video. Please like and share video and subscribe my YouTube channel Master Education. Okay guys.